Assalamualaikum and hi to all students. So we continue again today for lecture 9. Okay, basically it is a continuous of the previous lecture. Okay, but this one is about hypothetical testing to mean and proportion but for two sample. Okay, so previous one is on one sample, right? So this is hypothetical testing to mean and proportion of two sample. Okay. Okay, so for this course, basically, we want to learn on how we want to use hypothesis testing, okay, to compare the differences, because now this topic is on two different sample. So this is to compare the differences between the first one, two mean of independent population. Okay, so this one will be explained later. The second one, the two mean are independent. Okay, so one is in for independent population. So what is independent we'll explain later. Two mean are independent, and the third one is the proportion of the two population is independent. Okay. So independent sample. Okay, sample selected have different data sources. Okay, and it is taken from two unrelated or independent. That's why it's called independent. Okay, it is not related to each other. So meaning that we have two sample, different one, taken from samples that are not related. Okay, so samples taken from one population will not affect samples that were taken from other populations. So population A, let's say population B. So population A will not affect the samples taken from population B. Okay. So differences between two mean, okay, the first one of the objective of this topic, okay, is for difference between two mean. Okay, mean, average, same meaning. Okay, for independent samples. So now we are talking about the first one, which is independent samples. So we look here, okay, we have case 1 and case 2. Okay, so we have case 1. Okay, so for case 1, the sigma 1 and sigma 2. Of course, we have two sigma here, yeah, class, because we are talking about two mean. Okay, and two population, right? So, of course, we will be having sigma 1 for population 1, sigma 2. So, basically, we assume that both of the sigma, it is actually unknown, but we assume, we just put some assumption that it is the same, which means that the sigma 1 and sigma 2 actually the value are the same. So once we assume this, and of course it falls under this case 1, right? Okay, so we will be using this Pooled-Variance t-test. Pool because we pull together because we assume that the sigma 1 and sigma 2 are same. So that's why we put it as under this Pooled-Variance t-test. Okay, so now we move to the second case, case 2 here. Okay, basically sigma 1 and sigma 2, because we have two case here, two populations, two samples are unknown. Okay, same thing like case 1, but we assume that both of these sigma 1 and sigma 2 not the same, and we assume that it have large sample. So what does it mean? Again, of large samples means that your n is more than 30. Right? So if the sample is not large enough, assume for a normal scattered population. Okay, so basically you'll be asked on samples that is large enough. So for this case, we'll be using statistic z-test as usual. Okay. Okay, so hypothesis test for mu1 minus mu2, because we have two samples. So and this is for hypothesis test for mean, right? That's why we we use mu here, mu1 for sample 1, mu2 for sample 2. So mean 2 population and independent sample. So this is the case that we are discuss now. So we look here, we have 3 box here. I think that if you still remember the previous video, we also talk about this lower tail, upper tail, and two tail. So remember that for lower tail, it is basically on your your alpha, we don't need to divide by 2 because it is one tail. But for one tail cases, we have lower, because lower, if let's say your H alternative, it is stated that it is less than. So when you see this symbol, of course it refers to lower tail. Okay, so lower tails means what? Lower means your left side, so we're talking about this negative side here. All right, so when we talk about upper tail, again it is falls under one tail category. So of course your H alternative symbol will be more than. So more than, remember, of course it should be on your positive side, and your alpha, you do not need to divide by 2 because these both are one tail. All right, so basically your assumption for you to make your decision or decision rule is still the same for this T statistic. Okay, same like in previous previous chapter, lecture 8. All right, and so again for two tail, of course two tails, it happens when your H alternative is in this symbol. Okay, mu1 is not equals to mu2. Okay, but the difference between this chapter and the previous one, of course, because the previous one we involve only one population, right? So of course the mu is not equals to some figures or numbers of that particular statement. So for this case, okay, mu1 is not equals to mu2 because we're talking about two sample here. And when you talk about two tail, okay, two tails mean we have this left tail, which is your lower tail, and involve together your right tail. So of course your alpha, you need to divide by 2 here. Okay, so class, please remember, when it involves two tail, your alpha need to divide by 2, then only we do what? We refer to the table. So for this case, we need to refer to what table? T table. Okay, T table. So let's say you're given your alpha is 0.05. So what do you need to do, class? 0.05 for two tail, which means that your 0.05 you need to divide by 2. So when you refer to the table, you are referring your alpha value as what? As 0.025. That's just for example, okay class? So it depends on what is the value of your alpha given in your question. Okay, so then you take the value of the alpha and divide it by 2. Okay, then only you refer to your T table to get what? To get your T critical value. T critical value is the value that you get from what? From T table. Okay, T statistics is is the value that you calculate. Calculate using what? The formula. Okay, so you have to remember that and differentiate of that critical value and statistical value. Okay. Okay, so for this hypothesis test, so we are talking still about the same category here. Hypothesis test for two independent sample mean. Okay, so just now I mentioned that we have this pool variance, we have this use T statistic test. Okay, so it depends on your assumption of your sigma, right? Whether the value is the same or not the same. So assumption that samples are selected at random and independent. The population is normally scattered or sample size for both at least 30. Of course, this applies for both cases. Population variance are unknown. Okay, both are unknown actually under pool or T statistic, but we assume either it is same or not the same. So for example, for this pool variance, of course, we know that the sigma 1 and sigma 2, okay, unknown. Okay, but it is not for pool variance we assume that it is same, but for T statistic, okay, we assume that your sigma 1 is not equals to sigma 2 here. Okay, so of course in T statistic, when you want to calculate this or refer to the table, you need to have your degree of freedom. But for this one, because we have two sample here, so when you involve two sample, of course you have different n value for sample 1, sample 2, right? So your degree of freedom will be n1 for sample 1 plus N2 for sample 2 minus with 2. Then only you'll be getting your DF or degree of freedom for these two sample mean. Okay. Okay, now we look at the example for this first category, which is Pooled-Variance t-test. So, you are a financial analyst for a brokerage firm. You want to investigate whether there is a difference in the returns between listed NYSE and KLSE stocks. So, we assume that the data collected is, okay, so here for first category NYSE, the second one is BSKL. So we assume that two normal scattered populations, okay, of NYSE and BSKL with the same variance. Is there a difference in the mean return, which is your, and so here we assume your alpha as 0.05. So it's given in the question here. Alright. Okay. So for this particular question, okay, calculate your statistical test. So basic thing, when you want to do hypothesis testing, always we put first our hypothesis. So we have two, H null and H alternative here. Okay, so H null, remember that we are talking about two sample, right? So of course you involve mu1 and mu2. Okay, why do we write this as mu1 minus mu2 equals to 0? It can because we are assuming that mu1 is equals to mu2. So when you bring it on the left side, it becomes u1 minus u2 equals to 0. So either way, it's just the same thing. Okay. And because you want to assume that H null is opposite, H alternative is opposite of your H null. Okay, so we'll be writing your mu1 for sample 1. Okay, not equals to mu2. Alright, so it's same thing as you write it as this way. So both ways are just the same. So settle with this of your hypothesis testing. Hypothesis statement for your null and alternative hypothesis. Okay. So now, statistical test. So you need to calculate first before you, and then also you need to have your critical value. So now your t-stat here is, okay, we look back at the question here. So now they have this x bar 1 minus x bar 2. Okay, so this formula fixed being used for your situation which involve two sample. Alright, so x bar 1, x bar 2 for sample 1 and sample 2, and you have the here mu1 minus mu2. So you see, how do they get this value of 0? Okay, look again at your hypothesis statement here, which is mu1 minus mu2 equals to 0, right? So how do you get this? Just you just derive from this statement, mu1 equals to mu2. That's our assumption. So we can get this equation here. So the value will become 0 here. Alright. And then for this S here, how this is what? 1.5021. Okay, so how do we get the value of this SP2 here? So you need to do some other calculations here in order for you to get this value of 1.5021. Okay, so we put here of your N1 minus 1 here, we refer to sample 1. Okay, and we take this 1.30 here from our sample standard deviation of NYSE. So we assume this as your sample 1, this is your sample 2. Okay, and you plug in here. Alright, and 21 here also you get from your, we assume this as sample 1, so 21 here. Same goes to BSKL. Okay, then you just plug it into this formula for each sample. Okay, so at the end you'll be getting the value of this 1.5021. So later, you plug in here. Alright, so the same thing here, N1 is just from your NYSE that you assume as sample 1. Either way it's just the same, 1 over 21, this is 1 over 25, and the other value you just plug in. Alright, so this x bar 1 minus x bar 2. So the 0 also you get from your hypothesis statement, and then you should be getting this 2.040. Okay, and again this is from calculation, we call it as t statistic. Right. Okay, so for this, okay, still remember in our lecture 8 that I've explained to you that you need to sketch this to get a better view whether it falls into this rejection area, acceptance area, or rejection area if you have two tail. So of course you will be having on your right side and your left side. Okay, so now you have calculated just now 2.040 is for T statistical value from your calculation. But for this sketch of this bell shape, okay, when you want to mark here on your left tail and a right tail, this value is the one that you get from critical value. What is critical value? You need to read from your T table. Okay, so you need to have your what? Your alpha, but because you have two tail here, so you need to divide your 0.05 by 2. So each tail be getting 0.025. So of course, when you refer to T table, you need to take what? Alpha equals to 0.025, and you need to remember that because this involves two samples, so your degree of freedom will be N1 plus N2. So your N1 is what? N1 is 21, N2 is 25 minus with 2 because you have two sample. So of course this is your degree of freedom that you'll be getting, and you need to use this information to read from the T table. So basically this is the value that you'll be getting. Okay, this will be your guidance. Then you will compare with what? With your statistical test T value, with which is 2.040. So when you look at this value, it falls under which one? 2.040. It is under rejection area. Okay, rejection area means you reject H null because your T stat is more than your value of your critical value here. Okay, because it is 2.040 more than 2.0154. So conclusion, okay, means that the steps, if you see, it is just similar to the previous chapter. It's just that class, this involve two sample. Of course, you'll be saying this mean for sample 1, sample 2. That's the difference. But overall, the steps involved are just the same. Okay, so don't get confused. Okay, meaning that after you have the critical value, the T statistical value from this calculation using formula, okay, and then you refer to this sketch of your bell shape, and then you make what? Decision. Okay, to reject or do not reject. Okay, then you conclude. So conclusion, it is proven that there is difference in the mean between NYSE and KLSE stock. Okay, because you reject. Reject what? Reject H null. H null saying what? The statement. It assumes that it's the same, right? So when you reject, meaning that you accept your H alternative, which shows that your NYSE does not equals to KLSE stock returns. That's how you make the decision and conclusion. Okay, so now we move to the test for independent sample. Again, it always mentioned here mu1 minus mu2 because we're talking about two sample here. With variance assumed not equal. Just now, in the previous case, we assume that your variance are the same. Now, it is under the next category, which is variance assumed not equal. So, variance are unknown, still the same, but it assumes that your sigma 1 not equal to sigma 2 and subject to conditions. Okay, as been mentioned just now, for figures N1 and N2, it must be more than or equals to 30, so no need population distribution assumption. So because under this category, we'll be using statistical test of Z. Okay, so basically because you assume the variance are not equal, right? So if you see here, you did not pull it together but separately, as for sample 1, as for sample 2. Okay, with S1 squared here and S2 squared here are the estimation for sigma 1 and sigma 2. Okay, so now we look at the sample for difference variance. So now basically this is the same example like just now. It's just that assumption that they are difference variance. Okay, basically the question are just the same. Alright, so if you see here, the Z test for hypothesis test here. Okay, sorry, but for this question, I think that the difference is that suppose the two normal scattered population with stock variance on NYSE and KLSE are 15.2 and 10.1. Okay, because this is the assumption that difference variance, right? Is the stock return on NYSE higher than the KLSE stock return? So that's why you see here your H null and H alternative here is a bit different. And when this happen, if you see that for H alternative here, your assumption, the symbol is more than. So this falls under one tail category only. And the one tail is the upper tail because it is more than. More than, so positive side. So we are talking about your alpha. We just take the whole thing, which is 0.05. We do not need to divide by 2. Okay, so critical value, again, remember that we are talking about this assumption that your variance are not the same. So we are using Z table. Don't make mistake. This is Z table. So Z table, we take the whole alpha and we take the value of Z here. Alright, but this is one tail, right? So only on the positive side. Okay, so statistical one is the one that you calculate. You just plug in the information given and then you'll be getting your Z statistical test value is 0.70. So this value, is it in this area or this area? It is in this area, right? What is this area? Acceptance. Acceptance means what? You do not reject or fail to reject H now because your Z statistic is less than. So the not kesimpulan ya, the conclusion, okay? Not enough evidence to show NYSE stock returns were higher than the KLSE stock returns. So this one depends on the question and also on your H null and H alternative. So basically, because you fail to reject H null, you just refer back to H null. What is your H null? So when you fail to reject, means that you have to accept your H null. So it comes to this assumption. Okay, now we move to the next one, which is hypothesis test for two dependent sample. So test the mean of two dependent sample. We use the difference between two dependent samples. So now we assume that dependent means it's like affecting each other. Okay. So the difference is we denote as di here equals to your x of your sample 1, sample 2. Okay. The purpose is to eliminate the variation between the two samples. So we have assumptions that this is pertaining the sample size lah. Okay. Alright. So differences to I for pet population match DI. Okay. So point size for mean population pair mu D is D bar. So this is point size for mean population pair. Okay. So D bar here is equals to the D equals to the differences to I for pet population. Okay, and then sample standard deviation also you need to minus of your DI, okay, which is your differences of this pet population, minus with your D bar here, your point size for mean population. Then you'll be getting for that sample standard deviation. Okay. So what is N? N is the number of pairs in the pet sample. Okay. So pet different tests. Okay, so here we use T statistic test here. Okay, for mu D. So this is the formula that is being used here. So you'll be using D bar minus with your. So D bar here is actually your average. Okay, for the pet sample minus with mu of D. Okay, the average. Alright, and SD also we have seen the formula previously. And then for this stat, of course, we need to have degree of freedom. So this involve only because it is dependent, right? So involve only n minus 1. Okay. So hypothesis test for pet different. Alright, so again, lower test, it is on your left side, upper is on your right, and two tail involve both sides. So I think I do not need to elaborate further on this. It's quite the same. Alright. Okay, we move to the sample, okay, involving this. Okay, so we look at this example, hypothesis test for dependent sample. So suppose a company sends a salesperson to a direct sales workshop. So does participation in the workshop affect the salesperson? So the following data has been collected. Okay. So this is the salesperson. We have 5 here, 5%. So total complaint for each of person before the cost and after the cost. Okay, so we see the difference. Alright. So here, we look at this D bar here. How do they calculate here? Okay, this is a summation of DI. So DI is actually your the difference for the whole for all the salesperson here. So actually you'll be getting the total of DI here is a negative 21. How do we get this? For each person, 6 minus 4, you get negative 2. After and before. So 4 minus 6, 6 minus 20, 2 minus 3, 0 minus 0, 0 minus 4. So basically you'll be getting negative 21. This is the difference. Okay, and divided by 5, you'll be getting negative 42 here. Sorry, negative 4.2. Alright, so for your standard deviation here, okay, so for each DI here, which is negative 2, we need to minus with your D bar, which is minus with negative 4.2. Okay, and then you squared your answer, which is negative 2 plus with 4.2, and then you repeat for the whole salesperson. Alright, and the total divided by n minus 1, which is actually 4. So you should be getting 5.67 here. Alright. Okay, so test for PET difference. Alright, so does the workshop cause differences in complaints received at the 0.01 level? So this is the toleration and this is the assumption for this question. So we'll be using alpha equals to 0.01 here. Okay, so your H null is your average in your PET difference. Here is no difference and here is not equals to 0, right? Okay, so your alpha is 0.01, your D bar that you get is negative 4.2. So this is your critical value that you get from your T table. So your degree of freedoms is n minus 1, which is 4, and your alpha is 0.01 divided by 2. Alright, so you read from your T table, you should be getting these two value. Alright, and statistical test is something that you calculate. Again, you plug in the formula for this PET difference, which is negative 4.2 minus with 0 here, and this is SD, the one that you calculated already previously. So you just plug in. So you get your T statistical value is negative 1.66. So negative 1.66 falls under what? Under this area, acceptance. So you do not reject your H null. So when you fail to reject your H null, okay, it is proven that there is no change in the number of complaints received, right? Because no change equals to 0, right? Okay, so we continue with proportion of two population here. Okay, so the purpose is to test the hypothesis or form a confidence interval for the difference in proportion between two populations. Okay, so this involves proportion of two population. So remember that we talk about proportion, we denote and we use the proportion of our desired item or variables as pi. So because we have two populations, so we have pi 1 and pi 2, right? So this is approximate point of the difference, which is for population 1, population 2 here. So we assume null hypothesis is true. We assume that pi 1 equals to pi 2 and pool the estimates of both samples. So the pool estimation for the whole population of these two population is basically your P bar equals to your x1 plus x2, and this is for n1 and 2 population 1 population 2. So what is x1 and x2? Is the number of occurrences required in sample 1 and sample 2. Okay. So proportion of two population, the statistical test is Z statistic. So we involve the Z stat. Okay, we have this for P1 minus P2, and this proportion 1, proportion 2, and we need to use P bar. So how do you get P bar? You see here, this is the formula for P bar. You just plug in. Okay, and for P1, how do you calculate this? P1 is for population 1, so you take, okay, previously we have only 1, right? So the calculation is X divided by N. So because now we have two populations, so we need to do for population 1, population for population 1 and population 2 here. Okay. Alright, so again, hypothesis test for two population proportion. Okay, it can involve lower tail test. So this is involve only one but left side, and one tail also, but this one is on your right side. So your alpha, you do not need to divide by 2, and remember that for proportion we use Z-stat, and this is two tail test. You need to divide your alpha. Okay. So example of a hypothesis test for these two population proportion. So is there a significant difference between the proportion of men and women who will vote yes for statement A? Okay, so in random samples, 36 out of 72 men and 35 out of 50 women informed they would vote yes. Okay, so now they give you also your alpha equals to 0.05. So now, how would you calculate this? The first thing, you need to describe your statement, your hypothesis statement. So hypothesis now, because now we're talking about two population proportion, right? So H now is your pi 1 minus pi 2 equals to 0, or we assume that pi 1 is equals to pi 2. Both proportions are the same. Alright, and of course your alternative is the opposite, okay, which means that it is not equal to each other. Alright, so the proportion of the sample is, so we know that from the question we have male and female, so we assume that this is variable for male for P1. Okay, so we take your X divided by N, so 36 divided by 72, so you'll be getting this for male, and then female also you need to calculate separately. So now the pool estimation for the entire population, okay, the pool estimation P bar equals to X1. X1 is what? 36 plus 35 divided by your 72 plus 50, N1 plus N2. So you already get your P bar here. Okay, and then after you get that, okay, statistical test for pi 1 minus pi 2, or your proportion 1 and proportion 2. So you need to calculate using the formula, and also you need to take from the critical value of that Z table. Z table, because you know that it have two tail here. So we have this left tail, right tail. Okay, so you need to divide your alpha, which is 0.05 divided by 2. So that's why it is 0.025 here, and you'll be getting plus minus, which is negative 1.96 and positive 1.96. So now, how you want to make the decision? Same, you need to calculate for Z statistic to compare with your critical value. So once again, you already calculate for your P1, P2, and P bar. So you just plug in all the figures into this formula to get the Z statistical value. So from your calculation, you get negative 2.20. So again, we need to look at the sketch of your bell shape to see and to view in which area it falls into. So now, from your calculation, you get negative 2.20. So where about is it? It is here, right? It cannot be in this area. So what is this area again? This is your rejection area. So you need to reject H null because your Z stat is less than Z critical value. Okay, so when you reject H null, so there is evidence of a difference because your H null said what? No difference, right? So when you reject H null, there is the evidence of a difference in proportion between man and woman who will vote yes. Okay, so that is all for this chapter 9. And I really hope that you can understand clearly on this chapter through my video. Okay, so all the best, stay safe, stay at home. Thank you so much.